Okay, this video goes with the 1/6 additional practice. And let's see what we got here. So you're given that a conditional is false and its hypothesis is true. Determine whether the conclusion is true or false. So let's think about this. If you've got a conditional statement that's false, so you would start with like if P then Q, but the hypothesis part is true, but if the statement is false, that means that the conclusion part must be false. Otherwise, if they were both true, the statement would be true. So the conclusion must be false for it to be a false statement. Okay, let's look at number 2. Assume each set of given information is true. Use the law of detachment to form a conclusion. Now the law of detachment again tells us that if the statement is true, if the conditional statement is true, and the hypothesis is true, then the conclusion must be true also. If it's a true statement, hypothesis true, conclusion must be true. So these sets of information are true. So triangle is equilateral, then triangle has 360-degree angles. So if it's a equilateral triangle, then it has 360-degree angles. So if equilateral triangle, then 360-degree angles. Now in number 2, they're telling us that this triangle ABC is an equilateral triangle. So it's an equilateral triangle. So what does that mean? It must have 360-degree angles. So what can we conclude? 360-degree angles. Okay, let's look at number 3. If a parallelogram has 4 congruent sides and angles, then the parallelogram is a square. So if it's a quadrilateral, which is if it's got 4 congruent sides, it's a quadrilateral with all congruent sides. A square has all congruent sides, and all the congruent angles are going to be all 90-degree angles, so that makes it a square. So 4 congruent sides and angles must be a square. So let's do the symbols that go with that. So 4 congruent sides and angles. So let's do congruent sides and angles. 4 congruent sides and angles makes it a square, SQ. This parallelogram that they're talking about has 4 congruent sides and angles. Therefore, what do we know? It must be a square. Let's look at number 4. If the light is red, then you have to stop. So if the light's red, you have to stop. The light's red. Now this is a true statement. If it's red, you have to stop. Now the light's red. What does that mean? It means you have to stop. So that's the law of detachment. Now law of syllogism is like a transitive property. Like if A is equal to B and B is equal to C, then because B is equal to B, you got A equal to C. So the B in the middle kind of serves to transfer the link from A to C and make them equal to each other. Same thing's going to work with our logic in geometry. So if you want to get a black belt in, now assume that each set is true, and then we want to write a conditional. So you want to get a black belt in karate, but first you have to get a brown belt. If you want to get a brown belt, you have to get a white belt. So let's see what this says. So black belt requires brown belt. But brown belt requires white belt. So what can we say? If you want to get a black belt, you're going to have to get a white belt first, and then you work your way. So if you want a black belt, you have to get a white belt. So that's what we can conclude. Let's look at number 6. If a baby has a fever, then the baby is sick. So baby has fever, baby is sick. Baby is sick, then it has to go to the hospital. So fever means baby's sick. Sick means go to hospital. What does that do? It leaves us, if the baby has a fever, then it has to go to the hospital. So if fever, then hospital. Let's look at number 7. Suppose conditional P, if P then Q is true, and conditional if Q then R is false. So let's see what's going on with this. So they're telling us that P implies Q is true, but Q going with R is not true. So the two Q's hook up together, but we can't say then that P goes with R because this was a false statement. So it doesn't mean that it has to be false, it just means it cannot be determined. Well, let's see. If P is true, then Q, but this is a false statement, so it's not telling us that Q is true and R is false. So Q could be false or R could be false or some combination of those, so that's why it cannot be determined. Let's look at number 8. Represent each statement with symbols, then use the law of detachment syllogism to draw a conclusion. So Jalen rolls a number cube and gets a 3. So let's see what we can do. So let's use 3. So if he rolls and gets a 3, then he moves to a purple square. So, and this is a true statement. So he rolls a number cube, gets a 3, goes to a purple square. Now it says if he moves to a purple square, then he gets to skip his opponent. So these are the two things we have at work. So we can kind of see that with the law of syllogism, if he rolls a 3, he's going to get to move to a purple square, and because he moved to a purple square, he gets to skip. So if he rolls a 3, he gets to skip his opponent. So we go to the last line here. Jalen rolls a number cube and gets a 3. So he gets a 3. What does that mean? Ultimately, he gets to skip his opponent. Okay, so those are the additional practice exercises that go with 1-6.